recording. In our syllabus, you'll notice that there's a reference to mastery learning and the idea that the goal is to develop expertise, and there are two leading subject matter experts in that field, and one of them talks about gated challenges. So one of the challenges that we face in working with operating system concepts and flavors is that the landscape of operating systems often changes very rapidly, sometimes overnight. And as I was reviewing the content for the initial assessment, I thought, okay, there's a gap here somewhere. I picked up on it on my radar and I went back and checked. It has to do with the changes in the operating system that have occurred between server versions 2019 and 2022. And it has a lot to do with some strategic and industry leading or marketing interests, and it's confusing. And that's when I checked back and thought, this is something we didn't explicitly cover. So if you don't see this in your initial attempt at the Module 1 assessment, it's a pretty fair bet that when we go for a deeper dive and we refine our understandings, we establish where we are with concepts. After we've refined our understanding of concepts after the first attempt of the assessment, we're going to make sure that this makes the midterm and the final exam. And the reason we're going to do that is because one of the pressures that Microsoft has faced is this open source context, right? So in a nutshell, and by the way, can everybody see my screen and everybody's there on the same page? Yeah?
Yeah.
Okay, good. All right, so one of the things that's standard for Linux is that if you install a server version of Linux, it tends to be CLI, meaning command line interface terminals, no GUI, right? There's no graphical user interface. Well, that means for starters, well, and the other thing too is that Linux as an operating system tends to remove the permissive defaults that are standard in Windows and in Mac environments, where everything just works. And if you're a user on the system, you're allowed to read and execute at a minimum, which means you can get into Kool-Aid, right? I mean, maybe you can't make changes off the bat, but in many contexts, you can actually make changes. And that's too much latitude for people who are uninvited guests, right? So Linux tends to be more bulletproof for that reason alone. Microsoft began losing market share to Linux in part because of cost, but also out of security considerations. And one of the dynamics of security is this notion of footprint. Whenever you have a GUI in the mix, you have a lot more user mode real estate. So as you look at, everybody remembers kernel mode and user mode, yes? Kernel mode, user mode, the different structures of the operating system. We did structures of the operating system, chapter 2. Everybody remembers, kind of, sort of?
Yeah. Mm-hmm.
Okay. So if you have a graphical user environment for the operating system, there is a huge footprint. There's much more real estate in terms of OS resources that are extended out to the user for a graphical user interface. And in practical terms, it's much easier to navigate. You don't have to learn a lot of arcane commands with special switches in order to make things work. In the world of Linux, people often refer to that as knowing the proper spell. It's like you're casting a spell, like a magic spell, at the terminal prompt. It's actually kind of cute, right? So it's a nerdy thing to reflect to, but in any case, It's harder for hackers to get into the weeds without a graphic user environment, or more precisely, it's much harder for novice hackers, right? So there's a roster of hackers everywhere, and our goal isn't to prevent everything from happening. On a practical level, that's just not sustainable. But our goal is to eliminate the easy stuff, right? Let's not fall victim to simple things. Well, Microsoft in recent years was they were still out to conquer the world. So this idea that they're dominant to the extent that they were sued successfully, and US government action and actually European Union action legally in Europe was taken against Microsoft for monopolistic practices, right? So they were a monopoly, and that's against the law, right? That's not good. And there are some cases where organizations enjoy a monopoly, but it's a necessary evil, like public utilities and stuff, in which case we call that a regulated monopoly. But in the world of, in the wonderful world of information technology and in computer science and computer engineering, Microsoft was a bad apple. They had reached a state of dominance that was very oppressive. And so they were taken to task. They were taken to the tool shed and they were spanked, and they had to divest their two interests of operating system and office applications into two separate divisions. Part of the agreement for that resolution for that suit was, oh, you can't bundle apps into the OS anymore. You have to split those out. That has to be a different thing, right? Well, so it wasn't long before Microsoft said, okay, and they figured out how to dominate the operating systems arena. And this gave a lot of juice to the open source movement, because people were fed up with having to pay every time there was a new version of Windows coming out. Oh, open wide, another $100, another $100, another $100. So at the same time, Macs and Apple computers were gaining momentum because, hello, you buy them, you buy a Mac and you get free upgrades for the operating system for life, right? And some people started to realize, you know, you really do get more with a Mac. You really do get more with Apple with regard to certain resources, right? The rest of the industry started to see that open source was actually pretty cool, and that it was actually pretty secure. And in many cases, it was much more secure because it had a smaller footprint. Now, here's where we get to the GUI part. Microsoft felt like they were losing market share because in the server arena, Linux was gaining speed very quickly. At one point, the largest percentage of websites were actually operated on Fedora, CentOS and Red Hat Linux variants. And these are, again, no GUI, right? So when you looked out on the web and you did a survey, you're like, holy cats, it's like 40-something% or 50-something% of worldwide web servers are running Apache Linux. And that's a bad thing for Microsoft. That's like, oh my gosh, what is happening, right? We're not going to be able to market our one size fits all. That's a huge mantra. It's like if you're into the Microsoft Kool-Aid and you drink the Microsoft Kool-Aid, you're like, we have a version of Windows for everybody. Well, so starting with 2016, the version, so a version is denoted by the year. So if you're talking about a version of an operating system where Microsoft is concerned, different versions are denoted by the different year, and or in the same year by a separate release, R2. It's called release 2. So when you look at the progression of operating systems that Microsoft has released on the server side, they started with 2000 in the year 2000. And I was certified as a certified systems engineer, I earned that credential on Server 2000. And that was groundbreaking innovation. It was very different. It was very powerful. And a lot of things, that's when Microsoft was in it to win it with the server operating system. That's when things started to really percolate and change. And everybody adopted in the corporate world and government world this new Server 2000 platform, right? Well, give it a few years and everybody's saying, oh my gosh, this is a problem. It's a huge target, so every hacker is killing us. We're moving with a smaller footprint. In Server 2016, they created a version of the operating system that had no GUI, and it was called Core, just the core services. And you could install Core, and if you didn't like it or you had problems, you could convert Core into a GUI environment, and then you could convert back from GUI into the CLI only environment. So you could actually convert between GUI and non-GUI, and it was called Core. Now, with 2019, they dropped the label Core. So they no longer called it Core, they just called it Server. And if you wanted Server with a GUI, you had to choose the version 2019 or 2022 that has the desktop experience included. So if you just installed, starting with 2019, and you'll see references to Core all over the place. You'll see so this was big and everybody started adopting it and everybody started using Core servers. But then everybody was frustrated because, oh, I have to use a character line interface and the command prompt sucks. So PowerShell became the method, and PowerShell became the equivalent of the Bash terminal in Linux, right? So Bash terminal. So Microsoft's playing copycat. Oh, they have a great scripting language. It's called PowerShell, and it's just as good or better than Bash shell scripts. And a lot of the folks in Linux world are shaking their head going, no, that's not right. When you get to 2019, there's a marketing interest that becomes problematic for Microsoft. So they dropped the use of the term Core. And instead, if you install Microsoft Server Standard, that is without a GUI. In other words, they're so hard sold on a CLI version of their server, and they're hurt so badly in the server space that their standard version that you install in the install protocol, and I don't know if you remember this when you were installing your virtual machine, but it showed there was two options. There was just Server 2022 Standard and Server 2022 Standard with desktop experience. If you just accepted the default and clicked through that, you got a OS without a GUI, only the core. Only they stopped calling it Core. They didn't want it to be a thing anymore where it was a choice. They're trying to dupe people. It's like if you're installing the server OS and you just click the defaults, you're going to find out there's no GUI. And that's a gotcha. But the whole footprint thing takes on a whole new twist. It just so happens that as the Internet of Things started to evolve, a lot of firmware was based on a Linux kernel. Can anyone think of your favorite Linux kernel that runs on most smartphones? What's the name of that? What's the version of firmware that runs on most Linux-based smartphones? What's the most popular flavor?
You mean Android?
Android, yes, thank you. The Android operating system, right? Well, this started freaking out Microsoft again. And they realized, oh, never mind servers, never mind desktops. What about the world of mobile devices? What about the Internet of Things? What about smart devices that are connected to the global internet? We have to pare it down even further. And they came up with this idea of the micro operating system, which wasn't their idea. It was already in existence. Android was a great example of a smaller, much smaller micro operating system, right? So Microsoft birthed Nano. And again, 2016 was when they first offered it. And you could actually download an ISO, install and run a Nano server on a hardware platform, like any other operating system, like a desktop or a server. You could basically download this thing and it would be a Nano edition. Now I want you to hear my words, a Nano edition of the same server version. So what's an edition of an operating system? In the client space, I am running Pro on here, right? So if I look and I look at the system and I pull system information about, and then I get into the weeds, I'm running Windows 10 Pro, but some of you are running Windows 10 Home Edition or Education Edition. So the flavor of the version, right? This is the version for the client, right? So Windows 8, Windows 7, Windows 10, again, it's a number thing, just like the number of the year for server. Server 2000, 2003, 2003 R2, 2008, 2008 R2, 2012, 2012 R2, 2016, or 2016, 2019, 2022, they dropped the R2 thing. They're just going by year now. Windows 10 has been around a long time, but it has new kernels every year. So it's actually a full rewrite, a totally different operating system. This version of Windows 10, you can't have a Windows 10 version in any edition, home, pro, corporate, enterprise, education, whatever, workstation, unless you include the version, an additional version number, okay? Because Windows 10 has been around for so long, you can't just refer to Windows 10. Windows 10 came out in 2016. And what is that now, 6 years ago? And there are 6 new versions of Windows 10. So in the client space, that's an issue. When you talk about version, you need to include the version identifier along with the primary version number, 10, okay? What about in the server space? Well, it's all about the number again. But when you talk about the addition or flavor of that version, Nano was the smallest by far. They had something that was supposed to be able to run on an ARM, meaning like a smartphone processor, right? ARM processors, RISC processors, reduced instruction. Everybody knows what I'm talking about? Think Raspberry Pi, okay? Nano was supposed to be something that could run on very small devices, right? And in 2016, you could get different flavors of Nano for ARM, for different platforms, different hardware platforms. And you could install that like you could install Android. But then in 2019, Microsoft started mucking with it again, okay? They started messing with it again because what was big and hot in 2019, and it broke onto the scene with incredible fanfare, something called containerized apps. Has anybody ever heard of containerized apps?
I haven't.
Well,
I think I have an idea what it is.
so everybody knows that in Java, you have a Java virtual machine, right?
Yeah.
Okay.
Yeah.
So you write Java once, and then the virtual machine is actually the thing that changes from hardware platform to hardware platform. But in theory, when you do something in Java, you're not supposed to have to recompile something because it's on a different hardware platform, in theory, right? And that's how it's supposed to work. So it's this virtualization where you can kind of containerize. Well, the industry, when it got into the cloud, when we transitioned into cloud-based computing environments with operating system components to interface with the cloud, people started realizing, wait a minute, this whole virtual machine cloud thing is huge. And there are so many different flavors. How do we create an app that's going to run on everything? And somebody came up with a solution. It's called Docker, but there are other incarnations of the industry trend. You create a container, a virtual envelope, or a virtual environment that's self-contained, and you can drop that into Amazon Web Services or Microsoft Azure or Google data services or a Linux environment. It doesn't matter. And you're not having to rewrite the app because the container it runs in is well, forgive the pun, self-contained, right? Everything that's needed to run that app is included inside the container. Well, what do you need for that container to function properly? Oh, I don't know. You might need some components of the operating system because you still have to translate between the virtual layers and the actual physical hardware layers, right? So where are we going with this? In 2019, Microsoft came up with they changed the implementation of this server edition so that basically you'd have to set it up as a virtual machine on a host. So by the time we get to server 19, you're constrained to work in a virtual machine context running on a hardware platform that's running server 2019 as a host. Now it gets even worse. Okay, so what we're doing here is we're putting operating system resources and embedding them inside a virtual machine. And I've included a link here for you to read up on this because I want you to understand, okay, we have these small environments for connected intelligent devices, right? For intelligent devices that are connected to the internet, there isn't a lot of hardware. Think Raspberry Pi again. How is it that these things are able to do what they need to do? And how do you virtualize an app so that it runs on what? 57,000 different kinds of intelligent devices? And you're thinking to yourself, oh, that sounds chaotic. Well, aren't we doing that already? How many of you have like Hulu on your smartphone? Oh, but you have Hulu on your smart TV. Oh, but you have Hulu on your what? PC and desktop. Everybody understand what I'm saying? Does everybody get what I'm articulating here?
Yeah.
Containerized apps is something that is fueling and stoking an interest in software as a service. We said that there were 3 kinds of cloud-based. Isn't that in here? Isn't it in module 1? We talk about what? Infrastructure as a service, platform as a service, software as a service. Is this ringing any bells?
Yeah.
Have you guys been reading kind of, sort of, the addendum, I hope? The addendum, hello? That's
Yep.
also part of the study guide? Yeah, okay, all right. Thank you for tolerating my pushy verbalness right now. All right, so the thing is that software as a service, how do you make software as a service better? I don't know. You figure out how to develop the solution inside a container so that you're done. As soon as you're finished, you can drop it on any platform, local server or cloud, no matter. Doesn't matter, right? Where am I going with this? Nano provides those OS components for that virtualized environment that are used in this context or used alongside and in concert with or as a complement to a lot of virtual solutions and virtual environments, okay? The new focus is on containerized apps. Kubernetes is another huge leader in this market space. And the idea is that we're embedding operating system components into that virtual container so that it sits above and operates on anything else. Okay. So I have two links for you here, and I want you to understand. Now, this is progressing rapidly, and if you go from 2019 to 2022, there are additional what I would call stupid evolutions. It's like, okay, now we're taking Linux in the Windows environment, Windows subsystem for Linux, WSL. We can turn that on and run Linux in the Windows environment. But can we virtualize containers? It gets crazy stupid. People are trying, it's like having new toys and trying to figure out how to, oh, I got a racetrack and I got a train set and I got a baseball, all the stuff I need for my baseball team. So I'm bored and it's days after Christmas, but I'm not going back to school for a week. So what do? I don't know. I figure out how to, if I'm a kid and I'm curious and I do all sorts of goofy things, I might combine my like race car track with my train set with my, oh, and here the train runs into the baseball and it runs down the, it's called the a Rube Goldberg kind of thing. Look it up sometime. It's hilarious. And then there are great YouTubes, Rube Goldberg. So what do you have to know for this? I want you to be able to keep some of this separate. There's this thing called Server Essentials. And there's an edition or flavor of server that's Hyper-V server. And Hyper-V server is without a GUI, but it's a platform to host virtual machines. Essentials gives you everything you need for a small business. All of the email, all of the database, all of the file shares, all of the networking, everything in one, and you have your own domain. So you have your own custom email address, right? And it's all in one machine. All your eggs in one basket. Take 10, 12 different servers and fuse all of those capabilities into one install. Well, that's a really bad idea. It's like putting all your eggs in one basket. But if you're on a budget, you need all that functionality, then Server 2019 Essentials is a special license. It's a different edition of that version. And you can also download a free version you don't have to pay for, that's a Hyper-V server, because Microsoft knows, well, if you're going to set up a platform as a Hyper-V server, you're going to run Microsoft operating systems on it. And that's cool with them because you'll have to pay for the licenses that run on that Hyper-V server. So Hyper-V server is another edition, just like Nano is a different, just like Core is another. Does everybody understand what I'm saying? Now, where do you come in? When you hear Core, if that's a bona fide part of the OS context, you're dealing with Server 2016, and there are significant limitations and differences with that operating system. If you don't hear Core, but you hear desktop experience, and you're dealing with 2019 or 2022, you need to understand that some of those environments are CLI and there's no GUI. You also need to know that there are different editions of the same server version that are markedly different. And I use that phrase intentionally, markedly different. It's still the same OS kernel, mostly, but it's just implemented at a different scale, micro scale, small footprint scale, virtual machine scale, all in one, everything you need, including the kitchen sink scale. Yeah, and those are largely marketing distinctions. Why should you care? Well, if you're working with operating systems and you deploy the wrong one for your given interest, if you don't understand this, you're going to waste a lot of money and people are going to think that you're not really a subject matter expert. You don't really know operating systems. Not at least Microsoft operating systems, and they still dominate. They're still 4 out of 5 everywhere you go for technology infrastructure. So I wanted to take the time to flesh out this, these related concepts, the difference between the term version and edition, all of those different series, right? The series of versions from the beginning, 2000, 2003, 2003 R2, 2008, 2008 R2. So R2 is like a 2-year new version So 2003 R2 is like server 2005. 2008 R2 is like server 2010. See, and they did that again one last time with 2012. Server 2012 R2. It's really more like server 2014. Different operating system, different kernel, different, very different, because of all the hacking and all the stuff that have gone on, right? And all the market influences. Are there any questions about, in the Microsoft world, what constitutes a different version versus a different edition? In the server world, you have Nano, Core, Standard, Data Center, but then you also have these weird cases, Essentials and Hyper-V Server. In the wonderful world of client Windows, you have Windows 7, Windows 8, Windows 8.1, Windows 10, but then when you get to Windows 10, you have Windows 1609, Windows 10 1609. Oh, Windows 1809. Well, that's from 2016, or that's from 2018, or that, and they are completely different operating systems. So in the development scenario, when you're trying to develop a solution, OMG, can that be a challenge, right? Oh, it's all supposed to work automatically. It doesn't. What's the solution? Containers. And operators are standing by. Look no further. You should adopt Nano in a Docker and Kubernetes environment. So are we going to afflict you with implementations of Nano and Essentials? Well, only if you want to do it for additional credit and you'd like to test. Now I'm speaking to some students in this class here who have a keen interest in independent research. Do I have the attention of some of you?
You do.
Okay, so independent research, right? Independent research. Oh, we have Luke in twice. Yeah, Luke, for some reason you're connected twice. That's kind of weird, but okay. No, let's get back to this. You may be interested in performing or investigating the fact that there is a way to do Nano, a version of Microsoft Server OS as a Nano implementation in a containerized environment. And because it's such a small footprint, well, it might be more secure. Or they might have just thrown something together because of market interests quickly, because they don't want something taking off without them. Microsoft cannot be in a place where the rest of the world and those Linux lovers move on to something cool. And there's plenty of Linux platforms that run containerized solutions that have nothing to do with Microsoft whatsoever. And it's killing Microsoft right now. Well, I wouldn't say it's killing Microsoft. It's a major strategic emerging market interest that's going to change the way things work. We've already talked previously about the hardware innovation known as Xpoint, right? Optane and Xpoint, how it's both RAM and hard disk all in one, and how OS kernels are still conceptually devised to work how? Well, with I/O for the persistent storage, for non-volatile memory, for file access, right? That's how most operating systems are still engineered, architected. Why is that a thing? Well, if you have a new digital component that does the job of RAM and hard disk, do you have a von Neumann model anymore? Short answer is no, you don't. You really don't. And do you have to work with processes, with memory management in a virtual context in the same manner? No, What kinds of innovations are possible there, right? So I want you to be familiar with the lingo. I want you to understand that server versions of Linux never have a GUI unless you install them after the fact, right? I want you to get the market space and what's out there and how they differ. And I did revise this. So in the previous version of this, I updated this. I mean, I had to tweak some things. And I'm calling those out because, well, this is the world we live in now. And it's all changed since I started teaching this operating systems course just 5 years ago, right? The entire landscape has changed in just 5 years. Any questions about the new and enhanced information and detail in this section of the study guide? Going once. Going twice. Okay. Everybody ready for us to pick up where we left off in processes?
Yeah.
Can we like take a short, like 30-second breather? Everybody stretch. All right, so we got about 25 minutes left of our class. Let's just pause for a moment. I'm going to queue up where we left off. I think it was here. I did go over this stuff in the recording to make sure that it was consistent between these two slides, right? We were talking about 16, I think. Yep, 16. That's where we were. That's where we left off.
Yep.
Okay. Okay, anybody need any more time? We ready to go?
I'm good.
Okay. Everybody else, I'm not hearing from you. We good?
Yes, sir.
Okay. We're talking about process, right? So as you virtualize the three functions of an operating system, virtualization, right? Concurrency, persistence or permanence, right? Non-volatile memory, file access, that kind of stuff. Disk and file access. Those three big OS functions, when you're virtualizing, you really have to understand the manifestation of those virtualized components. As you're firing up virtual implementations of the hardware devices in your system, and those are becoming ready for access and use, you have to use device drivers. In many cases, you have to schedule how those implement, and you have to control the input output and the CPU mix, right? So one of the things that we closed on in our previous class was short-term schedule. That's all about the CPU, right? So things that are CPU intensive would put a heavy load on the short-term scheduler. The long-term scheduler, you're talking about file access, storing in non-volatile memory. There is some CPU process, but not like this, right? So we talked about medium term scheduling. So let's say that you have a large landscape in your operating system environment, and so you want to accommodate short fuse interests. Has everybody heard the term cache before? As in not C-A-S-H, but how is memory cache spelled? Cache?
C-A-C-H-E.
Yes, thank you. C-A-C-H-E, right? So we're talking about temporary storage that's more accessible than traditional disk store. So when we talk about caching, we're talking about a method of storage that's closer to and faster than traditional file storage in a data file inside a directory that you have to write to and from a disk, right? So that's the context. When we talk about a lot of medium, when you have a large system that's supporting many users, so a multitasking, multi-user system would suddenly have an interest in a robust caching capability. Part of that caching capability is something that we refer to as swap file memory or page memory. You're taking a page of the RAM address range, those pages. So a chunk of a RAM address range is a chunk of memory altogether. It's often referred to as a page, right? So memory pages are the manifestation or used in this idea of caching to faster disk storage. So in traditional terms, a spinning disk platter, there are sectors on the disk that are much faster to access than the ones at the tail end of the disk or platter. Does everybody understand what I mean by that physical explanation? I think we went into some of that in computer architecture. You know, traditional hard disk is a platter that spins, or multiple platters that spin on their little heads, right? And it's circular. Okay.
Yeah.
Okay. All right. So the idea is you're going to identify a designated area where there's faster disk access, and you're going to be doing that swapping. So that's where the medium-term scheduling comes into play. Any questions about how medium-term scheduling bridges the gap? You have intent stuff on the CPU, you have stuff that's to and from the file, input and output, and then what's in between? Oh, the caching, page memory, swapping, right? File swap. It's called swap memory or virtual. In some contexts, it's referred to as virtual memory because it's like virtual RAM memory. It helps manage the bottlenecks. This is one manifestation of something we call the 80-20 rule. We did go into the 80-20 rule in module 1, didn't we?
Yeah.
Okay, good. Multitasking in mobile systems. All right, so what do you do with a mobile device that doesn't have the generous hardware resources that a PC or laptop have? This is kind of a point of embarrassment. I mean, this is just where I have to throw my hands up in the air and I'm tempted to run out of the room screaming, because it's like, okay, I know we're using the 30-year-old dinosaur book and it's the 10th edition of a guy who is revered worldwide for his operating system principles expertise. Yep, I get that. But really, my son has a Samsung phone that has more RAM and more CPU cores and more disk space than the laptop I'm using right now. And that's just a little embarrassing. What's the relevance of that statement, you might ask? Well, mobile systems, right? Oftentimes you're dealing with a lot of real estate constrictions, limited hardware resources. So the multitasking methods for mobile operating systems like iOS and Android are structured differently. It's important to understand that up until recently, where you could buy a Samsung phone that has more hardware muscle than my laptop right now. And I'm hoping that my family and my wife are watching this video at some point in the near future, because it's Father's Day and anniversary and birthday and stuff. And I'm just planting a seed here that it might be time for a new laptop. Just saying. Okay, let's get back on task here. Single foreground process controlled via the user interface. And then you have these background processes. Everybody's done this thing where you display your iPad or your iPhone or your Android, and hello, you have like, I don't know how many running apps in the background. Does everybody know what I'm talking about? does everybody understand the experience I've just referred to? If you double tap the home key on your iPhone or your iPad, then suddenly you have all of these different like apps running in the background, but they're not displayed in the foreground, right?
Yeah.
Okay. So what they do is they park. I would call it parking, right? So a background process is like what you get when you've gone on to another app. Does it close the other app? No, it's in the background, right? And it's just not on the display because there's resource limitations. Usually screen space limitations, okay? Androids run foreground and background with fewer limits, right? So what they're saying here is everybody should ditch their iPhones and buy a Samsung, or I don't know. What's your favorite Android phone other than a Samsung? Quick. I have an LG, and then LG quit making them, so that's a problem. Do we have any Android phone users that are not like Samsung?
Yes.
Okay. Right. I've heard the brand ZTE. That's one flavor. How about Motorola? Anybody had any positive experiences with Motorola?
They're okay.
All right. We'll drop that. One of the useful aspects of process management is something referred to as context switching. So one of the I'm going to repeat that. One of the common methods for process management is context switching. When the CPU switches to another process, the system must save the state of the old process and load the saved state for the new process via a context switch. Context of a process is represented in the PCB. Does anybody remember what that acronym stands for? Hello?
Repeat.
Process control block.
Thank you so much. I was asking, does anybody remember what PCB stands for? Yeah, it is process control block. Thank you, sir. Okay, and remember that the process control block is like a clearinghouse of useful data and information on a running process, right? So it's kind of a handy dandy Swiss Army knife that helps you manage your process. Context switch time is overhead. So as you're switching between contexts, the more you're juggling, the more overhead there is. So your system cannot do useful work while you're switching. Let's repeat that. The system does no useful work while switching. Now that's imperceptible to us because we're dealing with processors that operate in the billionths of a second. So the switch happens so fast, it's like our perception of useful work happens in the hundreds of, seconds or tenths of a second. We don't perceive millionths of a second or billionths of a second, hardly. It's important to understand, though, that while context switching is occurring, the system is not working. So it's considered overhead, right? The more complex the OS and the PCB, the longer the context switch. That's sensible. I mean, that's logical, right? Time dependent on hardware support. So if you have a very fast SAN, storage area network, versus a very slow legacy NAS, network attached storage, oh my gosh, the context switch when there's read and writes between file IOs can be magnitudes, it can be orders of magnitude different. Orders of magnitude different. And that becomes significant when you're supporting multi-user systems. I mean, I'm talking systems that support thousands of people, right? As opposed to just one device that's supporting a single user who is juggling. Totally different context, pardon the pun. Totally different environment, right? Does that make sense? Operations on processes, right? So what are the basics for processes in terms of how the operating system works with them? Well, you create a process, you terminate a process, and then there's all sorts of other cool stuff. Oh, a original legacy process, remember, has a, what does each process have to have in order to work? It's a related concept. And every process has to have at least one. Does anyone remember from our last class? A thread, a primary thread. Everybody remember that? Oh, all right, maybe not. Parent process. Okay, so you can have a process that spawns children process, which in turn create other processes, forming a tree of processes. All right, so that gets to be a little sticky. You will find in the services option of Task Manager that you can kill a tree, right? And that's the reference there, is that you had a parent process, then there are child processes, and together it's like a tree. A good example of this might be the lowly, ubiquitous web browser. Is everybody with me here? Or email client. Let's say you're using something like Outlook, okay? So let's pretend that you have the main screen and the main window, but then you also have other windows where there are open messages in separate windows, or in the browser view of things, you would have a browser window, but then what do you have for some users all across the top of that browser window? Tabs, right? So you can have separate browser windows, but then in each window you can have separate tabs. And what's the point? I'm trying to tell you that when it comes to solutions that operate in that context, you're going to see more of this in the mix, right? It's just logical. You're going to have parent processes that spawn children processes. Another thing that you're going to see are network services that do the same thing. So whenever you keep recycling a resource, a parent-child process and tree processes is important. We did reference this thing called a PID, didn't we? Process identifier. Now this is critical right here, okay? What comes next is really important to understand. You can have a parent spawn a child, but there are resource sharing options and execution options. So the parent and child can share all the resources. That's one way to provision parent-child processes. Another way to provision parent-child processes is where the children share a subset of the parent's resources, but the parent does have some separate resources all to themselves. This would be kind of like our family environment in real life, right? Okay. Most children don't share the credit cards and the cars and everything else in the household, right? And then parent and child share no resources. Yeah, I'm not going to use the family example there, but you get the point, is that you can spawn a child and the child is completely autonomous and independent of the parent and doesn't use any of the resources. So those are the three resource sharing options. Fairly logical. Any questions about resource sharing options? Any questions?
Yeah.
Look at this one here. Execution options. Parent and children execute concurrently. That means simultaneously. So parent spawns a child, both parent and child are operating simultaneously, and they might be operating autonomously on top of that in terms of resource sharing, right? So parent and child executing concurrently, all right? Parent waits until children terminate. So that's the other option, is that the parent spawns the child takes it away, child's having a great time on the playground. When the child process terminates, then the parent can do something else, right? Does this make sense? I hope so. I want to take a short pause here to show you this. Everybody see my screen here?
I can.
Okay, and this is, what's the name of this tab at the top? Processes. Yay. Can everybody see these certain tasks that have extras on them?
Yeah.
Okay. So here's one that's service host sysmain, right? So I can stop this evolving thing here. I'm gonna hit here and just kind of freeze this. So I order this. Let's look at, well, that's interesting. I didn't know I had a calculator open, but I was doing some things where I embedded one application inside the calculator, and I wonder if I ever undid that. You didn't hear that, okay? Here's an Adobe Acrobat update service, right? And what you can do is right-click this and end the task. But there are occasions where you can basically kill the tree. So there are cases where there's an extra option for killing the entire parent and the children. And this isn't exactly the greatest example of that. The trick is to find something that has maybe this one. End task. No, right. So sometimes there are context options with the right mouse click that allow you to kill not just a child process, but the whole enchilada, the dependent processes. Any questions? Okay, we have 3 minutes to blitz. Everybody, deep breath, okay? Are we there? A tree of processes in Linux. So this is a flow chart which diagrams the stepwise and iterative aspects of how a process in Linux forms a tree. Once again, a tree is a parent that spawns more than one child. Everybody understand when we say tree, a parent that is spawning more than one child, and they're different children, okay? All right, so you see that we're doing some swap stuff. So what kind of scheduler would be involved with this? Would it be short-term CPU, long-term IO, or the medium thing? Does everybody understand the context of that question? I'm just checking for comprehension here.
Not really clear. Can we repeat one more time?
You see this part of the tree process formation in Linux, you see the magic word swap. If we were talking about the scheduler, the type of scheduler associated with this part of the process, right? Would it be short term? Would it be long term or medium? Short term, long term involves IO, medium involves caching, medium term scheduler. Oh, by the way, look at this diagram. Does that look familiar? Did you notice this diagram? That's for the medium term scheduler. And look, did you catch this? Should we put these side by side, or would you trust me that they're pretty much the same diagram?
So basically,
It's the same diagram, right? That's why I called that out. I said, okay, what are we dealing with in terms of a scheduler method for this medium? Right? Just saying. All right, so process creation. This is the and this is where we're gonna wind it up here. It's 12:15, so we're gonna cover this last moment, this last process creation. Pause button up the trail on. Oh, by the way, for you, attempt of the announcement line 259 Saturday. So process creation, right? You have to deal with address space, and you have to create an address space based on the parent, and then you have to load the program into the child address space. And here you see Unix examples. There are two manifestations of process creation, fork and exec, and they are used in a complementary manner with each other. So fork system call creates new process. Exec system call used after a fork to replace the process memory space with a new program. So kind of like a Texas two-step, and those two are used in collaboration with each other. This is Unix and Linux process creation. Your mileage may vary when we get to Windows. We'll stop here. Does anyone have any questions?
None for me.
Okay. I think it's best if we stop here. I appreciate your joining us today. Good luck with your Module 1 assessment. Remember the new concepts we introduced and covered in that updated section of the study guide. And if you have any questions or concerns between now and next Tuesday, you know how to reach me.